Okay, well, thanks everyone for coming. My name is Scott. I'm the product owner for the Data in Motion team, which is one of the core R&D teams within Cumulocity. You're about to find out what it is that we do in that team, and brought my colleague Rohit, who's a senior engineer on that team, to talk about some of the role of asynchronous messaging in the Cumulocity platform and some of the features we've been developing that make use of that technology. So the technical track, we are going to dive fairly deep into some of the technical topics, particularly dealing with some of the feedback we've had from customers about some of these features recently. So I want to start just by introducing what is this messaging concept for people who aren't familiar with it, how we're using it within Cumulocity, and then we'll talk about the notifications to feature, which some of you probably are already using, and if you're not, you should be, but there's a few things you need to be aware of about how that works to make sure you're using it as effectively as possible. And then Rohit is going to tell us about a new feature we have coming up, hopefully later this year, fingers crossed, called MQTT Connect, which is pretty exciting in itself, but it's also sort of an introduction to a new way of getting data into Cumulocity that you're going to see rolling out more widely over the coming months and years. And we should have some time for Q&A at the end. So, getting straight into it, messaging and Cumulocity, what is that all about? So, maybe we can have a quick show of hands. Who's familiar with the concept of asynchronous messaging and publish, subscribe, that kind of thing already? Okay, about half of you, so I don't need to go on too long about this. So the concept of event-driven architectures is pretty common outside of the IoT world. That's a really common approach for developing loosely coupled distributed systems, very widely used in business integration applications. And the sort of core idea behind that is this publish-subscribe communication pattern, where you decouple your publishers and your consumers. You have publishers who are generating events, pushing them onto queues, and then on the other end you have consumers pulling the events off of those queues and doing whatever it is they need to do with them. And the key thing about queues is that when you read something from a queue, you read it once and then it's gone. But we can also extend that idea to the idea of topics, where basically the same idea. You're pushing events, pushing messages onto a queue, but you can consume them into multiple consumers. So this idea of fan-out, where multiple things can consume those messages, which lets you distribute your data out to many different consumers if that makes sense for the application. So that's the general idea. Now, why is that useful in an IoT context? And I think the real benefit is the standard benefit of publish subscribe. Really, it lets you decouple your producers from your consumers. So your producers don't need to know and don't know who's consuming their messages, and likewise the consumers don't know who was sending to them. And you have this idea of being able to fan into a topic and then fan out again with multiple producers and consumers. So it's a very flexible way of doing asynchronous communication. Your producers and consumers can speak different protocols. No need for everyone to be talking the same API or the same protocol. And you can do really clever things like having filtering and transformation of those messaging streams done within your platform. So overall, it's actually a really good fit for a lot of the more sort of streaming-oriented use cases we're starting to see within Cumulocity and within the IoT world generally. And if you're familiar with the IoT hub products that a lot of the hyperscalers offer, they're already using this kind of messaging paradigm for pulling the data into the platform and distributing it to the places it needs to go. So, how are we making use of this within Cumulocity? So this is where we started a couple of years ago on this journey that we're on. This is how message routing was traditionally done within Cumulocity. You've got your Cumulocity core, which is this big monolithic piece of software, replicated for high availability, but still a monolith. Data comes in, and then there is a pretty much hard-coded, fixed way of routing the messages out to the different things that need to consume them very hard to change, very hard to add new consumers onto this setup. So okay, that was great for a while, but we want to change that. And we're moving towards an architecture that looks a bit more like this one. And anyone who's heard anyone talk about messaging before will have seen a diagram like this. So what we do is take that monolithic core and start to break it up into independent, collaborating services. Exactly how it gets broken up to be decided, but that is definitely a work in progress. And all of those pieces can then communicate between each other using this asynchronous publish-subscribe messaging concept. Synchronous request-reply communications obviously are still possible and still needed in some cases. That doesn't go away entirely, but you have this asynchronous communication there as well. And we'd like to get towards a world where all of the data in motion, so all of the sort of live data, your measurements, your events, your alarms coming from your devices, where all of that data comes in initially through the messaging service and then gets distributed out to all of the different parts of the system that need to consume it, whether that's a Palmer or the data broker, data hub, some other microservice, even the database will be just another consumer hanging off the messaging service. So the messaging service already exists, already part of the platform, and we're using a third-party product called Apache Pulsar to provide that functionality. And there are some optional features of the platform that already make use of it, which some of you may already be using. The microservice-based data broker, notifications too, which I'm about to talk about in a bit more depth, and this in-development MQTT Connect feature that Rohit's going to tell us about. So, moving right along, we'll get on to notifications too. So, why have we built this? So, the core goal is to provide, as I've been saying, this idea of reliable asynchronous delivery of real-time notifications to your Cumulocity clients, your applications, your microservices, that kind of thing. We want to have flexible subscription mechanisms, so you have a lot of power to decide which notifications you want to receive and take advantage of this decoupling of producers and consumers that the messaging approach gives you. We want to have at least once delivery guarantees so that you know you're going to get all of your messages. Maybe you get duplicates, but we guarantee that you don't lose anything. And we want it to be very scalable and very high performance. Of course, you always want those things. So that might sound a bit like the existing real-time API that already is there in Cumulocity, and it is, but we want to go beyond what real-time offers you and address some of the limitations of that API, particularly providing those delivery guarantees, which you don't always get with existing real-time, and the scalability. The real-time API currently is very tied to the individual Cumulocity cores, so we want to have something that's a bit more independent and a bit more easy to scale up. So, be careful how I say this. It's eventually intended to fully replace the real-time API, but not immediately. We don't have complete overlap of the functionality or of the APIs yet, partly because we're still trying to understand how people really want to use it and developing the API sort of iteratively as that process goes on. But ultimately, yes, I think you'll see this fully replacing the real-time API. Now, time for some technical content. How does it work? How is it put together? So there are three layers, and we'll start from the bottom. So in the Cumulocity core, you've got things that are generating notifications. So that could be incoming measurements or events from your devices. It could be changes to the inventory or some other type of event that's being generated internally within the core. And these are the same kind of things you can subscribe to with real-time today. And you can create a subscription to receive those events. And then we move on to the next layer, which is our messaging service, where those subscribed events are pushed into topics within the messaging service. And you can see the idea of the fan-in here, where we've got multiple subscriptions pushing into the same topic. And then the top layer is our applications, where we subscribe to these topics and consume those events. And again, here's the idea of the fan-out, where I've got two consumers attached to this topic, and each of those consumers will be receiving a copy of all the messages that go into that topic. So very flexible. The topics are sort of the core thing within the messaging service, and you can push multiple streams of messages into them and have multiple copies of those streams coming out of the other side. So there's a two-step process as a user of this API. First, you have to create your subscriptions on the core side, and then you create your consumers out in your application. And those could be done completely independently. So again, decoupling, which is a word I use a lot. And of course, the messaging service is giving you persistent storage of all the data on the topics and guaranteeing that it will be delivered to the consumers. As I say, beware. If you read the documentation for this API, we use the term subscription in a few different ways, which can be a little bit confusing, because there are two types of subscription involved here. Firstly, these ones on the core side, where you're subscribing to the notifications within the core. And then we also talk about creating subscribers to actually consume the events on the other side. They are different things, but that's not always obvious. So that is definitely something you need to keep in mind. And I think we would like to change those names. But for right now, they are what they are. Now, to go into even more detail, because, like I say, there's a few gotchas with this API that we want to cover. Looking at each of the two steps in this subscription process separately. So as I say, first of all, you want to subscribe to your core notifications and push those into topics. So in this case, we're subscribing to temperature measurements from a couple of managed objects, a couple of devices, and we're also subscribing to all the alarms from our tenant, just as an example, and pushing those into two different topics. So for people who are familiar with the API, you'll know that when you create these subscriptions, you give one of the parameters you give is the name of the subscription. And now, what we don't tell you currently is that name is actually the name of this topic. So this is why you can create multiple subscriptions using the same name. And what's happening under the covers is all of those messages are being pushed into a single topic. So each topic really defines a stream of notifications that could come from multiple subscriptions that you want to receive in order, possibly across multiple consumers. So there's a couple of best practices that sort of follow on from that. One is that you should probably try to use as few topics as possible. We see a lot of people, they will create a subscription with a different name, meaning a different topic for every single one of their devices, which will work, perfectly feasible way of doing it, and if it makes sense for your application, fine, no problem with doing that. But typically that's not what you want. You want to combine all of those measurements from all of those devices or from some group of devices together into one stream and consume them all together. So you should have a single topic for that, not hundreds or thousands of separate topics. And I don't have time to talk about all of the different consumer types that we can create, but there is this idea of shared consumers, which basically lets you have a horizontally scaled out consumer so that you can consume the messages in parallel when you get to that end of the process. So if you're worried about the performance or the scalability of your application, if you're funneling everything through a single topic, the shared consumers can be a way to get around that. Now, I have even more detail, don't I? So to make these subscriptions, you're going to do a post to the notification to subscriptions endpoint, and you give that a bunch of different information. And the really important thing is this subscription parameter, which here it's temperature. That, as I said, is naming the topic. It's not the name of this thing. It's the name of the topic that that thing is going to push the messages into. And you can see that with the next one, where, look at that, it's the same subscription name, and therefore it's going into the same topic. And for our third one, we use a different subscription name, and therefore it goes into the alarms topic, not the temperature one. So that's the core side of the subscriptions. And then if we move on to the even more complicated part, sorry about this, this is where we create the consumers on the other side. So to introduce another messaging term, consumers are what we call durable subscriptions onto these topics. So that means once the consumer has been created or registered as a consumer on that topic, as far as the messaging service is concerned, it continues to exist and it continues to be interested in receiving all of those messages on that topic until you explicitly unsubscribe it. So just being disconnected at the network level and not actively receiving messages does not mean your consumer has gone away. You know, the messaging service thinks, okay, you're temporarily disconnected, I'm just going to keep storing these messages for you, and when you reconnect, I'll feed them all out to you, which is kind of the whole point of persistent messaging, that we don't want to lose these messages. We're not going to throw them away just because you're temporarily disconnected. And this is a trap that I've seen quite a few people fall into. They'll just disconnect their consumer. The messages will keep piling up in the topic, and eventually we end up using up a lot of disk space and have to go and do some manual cleanup, which everyone wants to avoid. So remember that consumers, they're durable subscriptions. They need to be explicitly unsubscribed when you no longer want to receive those messages. And now we make the link between the consumer and the topic using a token, and this is a security mechanism to allow. Really, it's decoupling of the permissions. So really, the token is just the permission to create a named consumer. You need to think of it that way. It doesn't represent the actual consumer. It's just the permission for that consumer to exist. It'll become clearer in a minute, I hope, when I go through the example. So again, there's a few best practices involved here, which are mostly fairly obvious, I hope. Firstly, again, going back to this idea of the consumers being durable, your consumer needs to acknowledge that it's received every message. Otherwise, we won't know that we can delete it from the topic. So, good idea to acknowledge your notifications as soon as possible after you've received them. And as I was already saying on the other side, you know, create as few topics as possible, and also create as few different consumer or a few different names for consumers anyway as possible, because these names uniquely identify the consumers, and you don't want to be generating a new name every time you reconnect the same consumer, because what you're doing there is actually creating another one, and that'll be causing another copy of all the messages to be created, and then we're back to our problem of using up lots of storage. So keep your space of consumer names really small. Don't include timestamps or GUIDs or any other sort of generated data in there. Just give them clear, simple names that represent what they're going to be used for. And again, going back to the really key point here, because these unacknowledged notifications will be kept forever, you need to make sure you unsubscribe your unwanted consumers as soon as you're done with them. And again, we have an example. So to create these tokens, which you're going to use to create the consumers, you do a post to a slightly different endpoint. And there are two things, really, two important parameters you give to that request. First one is the subscription name, the confusingly named subscription, which again is actually the topic name. So this is how we make the connection to the topic. And then you give the subscriber itself a name. So this is our temperature subscriber, and I'm also creating two differently named alarm subscribers connected to the alarms topic. So as you can see, each of these consumers has a unique name, and each uniquely named consumer will be receiving its own stream of events. And in the case of the alarms, 2 copies of the events are going out everywhere. And yeah, and if one of those alarm consumers gets disconnected from the network and reconnect later, just give it the same name, reconnect using the same subscriber name, and it'll pick up where it left off in that stream, and there won't be any unnecessary duplication, there won't be any unnecessary buildup of events in your storage. So yeah, that's all the technical detail there. Those are all important things to know, and we are updating the documentation right now to reflect those things a bit better, since it's clear those are slightly confusing for people. Yeah, so just to wrap this section up then, where are we with this feature? So it's actually been available optionally in every deployment of Cumulocity since 10.11, which was quite some time ago now. And we've had it deployed by default on all of our shared environments, so cumulosity.com and so on, since 10.13. It's not available on Edge yet, and why is that? That's because we haven't been able to guarantee that Kubernetes was available on Edge until quite recently. But as you heard yesterday, that's all changing. We'll be able to have Edge deployed on Kubernetes, which means we can move towards having the messaging service and the pieces built on top of it as standard components of every Cumulocity installation. Everyone can take advantage of these features. So it's actually actively being developed as well. Notifications, we're working on improvements to the API and improvements to the user experience, which is clearly a little bit difficult and does need to be improved. And there are more exciting things than that going on, including working on an integration with Apama to give them a really high-speed, high-throughput channel into the platform so that they can consume data from Cumulocity at the speeds that the Apama engine is capable of doing. And finally, yes, so there is some sample code out there that shows you how to implement all of these best practices. Rohit's going to be updating it very shortly after this conference finishes. So don't click on the link immediately, but within the next few days, the code at the end of that link will be updated to reflect all the stuff we've been talking about here. Okay, and I'm actually doing pretty well for time. And at this point, I'm going to hand over to Rohit to talk about MQTT Connect.
Thank you, Scott.
Yes.
So, right. So we have started with this very much requested feature called MQTT Connect, where what we want to do essentially is decouple the protocol from the payload it's carrying. So if you're using our MQTT implementation already, you will be knowing that you can talk MQTT in really two ways, which is either our smart REST protocol or the JSON message format. Now, that would mean that you'll have to code your devices to understand these two message formats. And it's fine for a lot of our customers, but a lot of the customers, we can't make that assumption for everyone else, because a lot of the customers might be having their own, closed MQTT devices, which might be using proprietary data formats, and and also it's not necessarily true that our customers would want to build and maintain a heavyweight agent that does all this translation outside our core. So yeah, so what we want to do is enable our customers to easily integrate the devices that I was talking about, which might be using proprietary format, or and they don't want to build heavyweight agent outside the platform. So while we're at it, why not throw some MQTT5 features into it as well, so you could benefit from all the features that brings you. And of course, we'll still be supporting MQTT 3.1.1 as well. Right. What this feature would also enable you to do is easily migrate from other IoT platforms, such as Google and others who are retiring, to Cumulosity. So it will make that migration much simpler and straightforward than it is normally. Also, also, it's worth noting that that MQTT Connect is really our first example where we are moving the messaging service that Scott talked about into the ingress layer. So you could benefit from the nice architecture we're bringing into the platform. Right. That's the dot. OK. So how do we do this? So the approach here is really that we are introducing a protocol adapter at the edge of the platform. Now, this is really responsible for doing all your connection management and so on and so forth, what's typical of an MQTT implementation. And yeah, so and also it's worth noting that we couldn't get that in this image, that this component is horizontally scalable. So, well, it's really elastic in that sense. Now, the backend of that is, of course, our messaging service. I'm struggling with this. So the backend of that is our messaging service. So this is where the persistence of those topics and its data really happens. And this is what lets you, enables you to, send in arbitrary payloads and, and talk, arbitrary topics using MQTT. So, right, there's an asterisk to that. You can't quite, use any topic that you would like. There are few restricted topics, and they're typically the topics that our existing MQTT implementation already has. So, yeah. So except that, you can pretty much use any topic that you want. OK, so, right, that's all nice. But now, how do you get those? Sorry. Right, that's all nice. But how do you now get those messages into Cumulosity? Well, you could do that by using our mapping microservice. Well, you got to build that, but we are going to give you all the, and really nice SDK by which you can listen to the data stream that is coming out of the messaging service, and you will have to, basically use our existing Cumulosity API to ingest that data into Cumulosity. Well, that's necessarily not the only thing you might want to do. You may also want to, send that data across to a different service or do both. That's all, that's all that all depends on your use cases. Yeah. So, yeah. That's pretty much it. Right. Now, keeping in line with Cumulosity tradition, we're not, of course, going to say that, go on, just build your own microservice. What we have, and that's thanks to our pre-sale colleagues, is a really nice, really cool dynamic MQTT mapper. So what this enables you to do is basically map those arbitrary topics and payloads that I was talking about before into Cumulosity using this nice UI-driven service. This is also this is a community-supported project, and it supports various data formats. You might you might go and check that out, and we intend to support this out of the box. So, well, that eases your this mapping microservice that I was talking about. Right. So when can you get your hands on, hands on this? Well, at the moment, it's an invitation-only, private preview, and you can get in touch with our product management. Jane is here, to request this feature, and yeah. So as part of that, we'll be collecting feedback and taking it from there. Also, in the future, we intend to support beyond 1 million parallel connections. Why 1 million? Because that's an amazing feat that our platform has already accomplished, the current MQTT implementation. So our current MQTT implementation already supports 1 million parallel connections, and we intend to take it even beyond that. And also in the long term, obviously, we plan to move the current MQTT implementation into this really nice, shiny architecture so that you can benefit from everything Scott was talking about, so that. Right, so that's all I have for today. And I think we would break for questions now, yeah?
Yeah, absolutely.
Thank you.
Cool, yeah, so thanks for listening, and yeah, any questions? Of course, Eric has one.
No, can you go back to your slides? To the one where you saw the alarms consumers?
Want to come to that side?
Yes, this one.
There we go, yep.
So I got that the alarms 1 and alarms 2 are both getting the same alarms, so they both get all of them.
Correct.
Right. Am I also possible to spread the load between them so that I have multiple instances of them and they kind of get a load balancing made between them?
Yes, so that was, I mentioned shared consumers briefly, and that's exactly what they achieve. So each one of these, if you define it as what we call a shared consumer, you can have multiple instances of the consumer with the same name, and Pulsar will automatically load balance the messages across all of those instances, and it partitions it by the key, which would be the source ID in our case. So all of the alarms for device X will always go to the same instance of that consumer. And that's a very powerful feature that we added in 10.16, and so that's available now.
Cool, yeah. But I still have to unsubscribe them at the end.
You still have to unsubscribe, yeah.
Okay, good. Right. So then one question to the MQTT Connect, and that's kind of, am I restricted in terms of what am I sending? Because currently I'm more or less restricted to JSON stuff. I think that's quite common.
You wouldn't be with MQTT Connect. You could send any arbitrary payload on any arbitrary topic of your choice. But of course, like I mentioned, the existing Cumulocity topics, you can't use them because that means something special. So except those, if you know S/US and what I mean by that, apart from that, you're pretty much free to use any topic that you would like.
And whatever payload you want, as long as you can decode it, send whatever you like.
Cool, because I'm thinking more in the direction of devices, embedded devices,
exactly.
Sending a static payload. I cannot modify that. It's just giving me whatever it's programmed to do. Mm-hmm. So I can interpret that on the platform layer now, and instead of having to configure the device to send stuff to a certain payload that...
Exactly, yeah, that's the use case, and you don't have to then have an external agent and an external broker to do that mapping.
Cool, thanks.
Yep.
So I have a question to Apama first. So does it mean that we will have a horizontally scalable Apama microservice then, sooner or later?
I'm going to direct that to the man sitting behind you, who's the Apama product manager. Yes. I don't think I should dare answer that question. Rob?
A horizontally scalable Apama microservice. Yes, so streaming analytics. To make it horizontally scalable, it probably needs a few more things in the platform first. Streaming analytics uses the microservice element of Cumulocity, and that in itself, I don't believe, has the ability to spin up multiple identical microservices and then do load balancing across them, or sharding across them, I should say. But using the new messaging service that Scott has described is certainly a first step towards that goal.
Yeah, so certainly these those shared consumers I was just telling Eric about, that is something that Apama would be able to use to subscribe and consume in a horizontally scalable way when they have that microservice. So yeah, I think it's coming, but I don't think we can put a date on it yet.
And the next question is on the measurements and events on the tenant under the tenant context.
As in when will you be able to do that? Yeah, it's a tough question. We've been nervous about adding that because it does potentially create a huge flood of events that can cause all sorts of problems in the platform. And if you've tried to do that with the existing real-time API, you know it can cause problems. I think we are working on it, and the work we're doing with Apama is going to enable at least Apama to be able to consume.
Apama already is.
Apama will definitely be able to do that. I know Apama can cope with it, and we're working on a slightly different API to allow Apama to consume all of those messages efficiently. If that works out well, and if product management is kind of willing to go in that direction, we can talk about opening that up to other applications. But yeah, it's a work in progress, and we're very aware that people want to have that kind of capability. But I'd also like to be able to offer you a more flexible way of doing subscriptions, rather than this all or nothing single device or every device. You should be able to subscribe to device groups and be more flexible in what your application receives.
I have 2 more minutes.
Yeah, Hussein had a question.
Thank you for the MQTT Connect, long-awaited for feature. For the microservice, is this high available? The one that does the mapping?
The mapping microservice.
Yeah.
So the generic MQTTMapper, that exists as an open source project that our pre-sales people have produced. So yeah, that is available. What it doesn't have today, but it will have soon, is the direct integration with MQTT Connect. But at the time where MQTT Connect is actually available in the private preview, that will exist. So, and I assume you're going to want to get on the private preview, Sam. So, yeah, but yeah, you'll be able to use that mapper plugin at the same time.
Last question.
So I have one question regarding the MQTT Connect, so maybe you can go to that slide. Because, I mean, the current implementation on MQTT is that you have basically just one device that is bound to one device on the Cumulocity side. So how do you handle that in terms of authentication, that you basically cannot mess up anything, so you do not have a one-to-one relation anymore?
Yeah. Yeah, I mean, the simple answer is we just leave it all to your mapping microservice to make those decisions. Yeah, it is a slightly different concept, yeah, because you're connecting. I mean, I guess you know, with current Cumulocity MQTT, you effectively have a per device topic space, and you don't get to see the messages for any other device. In the case of MQTT Connect, it's a per tenant topic space. So yeah, you could share messages between devices on the same tenant, and the mapping from your external devices to your Cumulocity devices, you're responsible for that. So it's another one of these, with great power comes great responsibility things, I'm afraid.
Okay, thank you.
Thank you very much, Scott and Rohit.
Thank you.
Thank you.